Hi, my name is Andrew Greenfield, and today with Tom Bish, we're going to take a look at the FlashCore Modules anomaly detection or real-time ransomware detection on the FlashSystem 5300 in my lab in Poughkeepsie, New York. Now, Tom and I have worked together over the last, 6 years. He's a fantastic guy. He recorded all these scenarios as we want to do a deeper dive into various detection strategies that the ransomware scripts will use and how we can detect them using the actual onboard chips of the FlashCore modules. Now, for a recap for everybody, we need to do this faster, quicker, and even more granular to recover faster. So we have inside our FlashCore modules a nice set of chips that are intelligent, that are looking for various ransomware patterns, not just compression, but also entropy and some other things. This is well described in some of the other videos, which is available in the metadata. And we actually show this in a couple live items. And as part of this, the recap is all those FlashCore modules are looking at every single write and then analyzing those patterns and sending it up internally to an aggregation engine and then an inference engine, which is looking at all of those patterns and then talking using ML or machine learning models such as watsonx or AI up to our storage insights and then immediately sending out an anomaly workload detection alert. So this is a real-time alert and it actually will then show that. Now, I actually have this on just a one-on-one basis on this video right here that's published earlier. We've been doing this since 2023, but on this video, we're going to show some slightly different workloads and how those chips work even better than that first video using other VMs. So in my Poughkeepsie lab, I have 10 VMs. We're going to focus on just one VM to start, but then we'll span it out to a full 10 VMs. We're going to use an RDMA volume as well as a data store volume. All this is going to be on a Brocade fabric, the 64 port, 32 gig SAN switch in my lab. Now, in case you want to see more details, you'll see the actual RDMA volume at the top, 1 terabyte, and then I have a 25 terabyte ESX data store or VMDK that all of the VMs also are sharing. And of course, you see that I've only wired up 4 ports of the 5300. This isn't a performance test. And yes, I'd always recommend to use more ports, obviously, but I do have all of the bays populated with FCM4 drives. You can see the specs down below, and this is all on a Brocade direct fabric. The ESX hosts are Lenovo, by the way. So on every virtual machine, this is the first one, you have the file structure on the right-hand side where you have at least the RDMA volume on VM number 1, and then the rest of the volumes have a very similar file structure on their VMDK. Only VM1 has the RDMA volume though, and we'll start off with that in a few seconds here. We're doing this just because we saw some differences in the patterns of the writes and how that's detected differently. Now, let's talk about the current video. So scenario number 1 is on VM number 1, I have an RDMA volume, and I'm just going to encrypt that RDMA volume without anything else. So I'm only going to encrypt it from the encryption itself, not having other workloads. And you're going to see why this is different as I go through the other scenarios. Now, I'll be speeding up parts of this video so you don't have to wait too long. So basically, we're going to encrypt the RDMA volume. We're not going to do anything with VMs 2 through 10 or the VMDK. Now, on the left part of the screen, we're actually going to see that we've got nothing going on here. And Tom is doing a great job here where you'll see he's going to show the events and performance. So you can see we've got no events right now. And on the right-hand part of the screen is where he's going to kick off his wanna laugh encryption script or ransomware script. And you'll see immediately how the flash system springs into action and starts looking at those patterns and then immediately alerts. So watch this. Here we go. We're going to launch this in a few seconds here. You'll see the performance spike up, and we'll then see how quickly the FlashCore modules can respond. And this is the key thing here. So watch at the lower right how all of a sudden you can see the percentage. I'm going to magnify it now. So on the middle part of your screen, you can see 2 items, the percentage of how much it's encrypting the volume, and then the actual array itself's performance. You're still seeing the array is performing wonderfully at microsecond response time. But meanwhile, at 4%, that's right, see the alert that just popped up there. 4% is when we officially got the alert. This is great. This isn't 50%. This isn't 80%. This is at 4%, we can get the alert and immediately start taking actions and or stopping all IO to get the ransomware in a far earlier stage. So scenario 2 that we wanted to try is, okay, so now just one VM again, we're going to encrypt on the same volume that we're going to run a normal workload on. So it's still RDMA, still fiber channel. We're on a Brocade fabric, and we're going to now encrypt as well as have a normal workload at the same time to see if we can confuse the FlashCore modules. Now, you're going to see we're going to get into the other VMs later on to see if that further waters down the detection. But you're going to find it's actually got better in some cases. So here we are again. We've got nothing going on. We're going to go to events. We're going to clear the log and make sure we have a fresh, clean system. So on the upper right is where the ransomware is going to go. On the lower right, you can see we just kicked off a single IO zone workload, reads and writes. So that's going to go off right now. You can see that we're going up there. And now let's go back to our events so we can watch for the alert that's coming our way. So take a look. I'm going to magnify it up again. So you can see the percentage on the top part of the magnifying glass, files, and how long it's been running. And yes, it's sped up again. Notice the latency is still really good, less than 5 milliseconds. And the bandwidth reads and writes. Now remember, if this was performance, I would have wired up more ports and all the other stuff. But okay, so in this case, workload and the encryption at 8% versus our last run of 4%. So at 8%, we got it. That's huge. That's still a lot less than 25% or 50% that we can actually do something about it. So you'll see that we click on the refresh here, that sometimes it doesn't catch it as fast. But in this video, we actually stopped it and noted it as soon as we got the alert. So now let's try a different test. Same single VM running the anomaly or the ransomware workload on the VMDK as well as a normal workload. So this is the key difference here, is we wanted to see if there was any differences in how it was being written using the VMware file system versus RDMA. So you'll see there's going to be an interesting difference here. Let's watch it out. So compliments of Tom, we are now all set here where we actually have 0 going on the array. We're going to make sure to go up and check our events, make sure that's cleared. So you'll notice then on the right-hand side, we've got him starting the IO zone workload. Great. Remember, this is on the VMDK. The RDMA is still attached, but we're not doing anything with it. And then he's going to go up to the ransomware section and say, okay, great. Let's start the workload and as well encrypt it. You saw that with the last few seconds. Here we go. We're going to magnify up. And here is the progress. Again, you can see it's going. Latency is still in microseconds, outrageously fast for both of this. So for those who are tuning in late, microseconds, US is far better than milliseconds. And look, we caught it at 3%. So this is interesting that we actually found it a little bit faster on the VMDK. That's with the same test, same script and everything like that. We found it a little bit faster. This is very useful. Either way, it's still great news, the fact that we can detect ransomware far, far faster. So now, scenario number 4, paying attention, we're going to start using the rest of the workloads. So VMs 2 through 10 are going. We're still going to encrypt the RDMA first, just to try it out again. And we'll have normal workloads on all the VMDKs, as well as all the other VMs. So all this is on the single Flash 5300 in my lab in Poughkeepsie, New York. And we're going to encrypt the RDMA volume by itself, along with the workloads that are just going to run by themselves. So you can see that Tom now has done a great job giving us extra tabs in the lower right. You can see we've got no workloads going on right now. And we're going to start off all those workloads in just a few seconds. We're going to go to our event log. You'll see that it's clear. Now he's going to bring up all the workloads here. So workload 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So we now have 10 workloads going plus the ransomware. You'll see he gets going in just a few seconds here. So as expected, we see our IOPS going up, our reads and our writes from the IO zones that are kicked off on each one of those. I'm going to magnify up. So we launched the wanna laugh script. And now let's magnify up the actual progress of everything. So here we go. We've got nothing in our event log. And you can see at 1%, we're all doing so well. You're right, with all the workloads, I've crept up a little bit to milliseconds, but at 2%, we detect it. That's even faster. We found it out with even more workload. We found it faster. Here's the alert. This is great. This is absolutely fantastic that we found it in a fraction of the time with more workload. In other words, it was working even harder to try and find the patterns. So our next scenario now is we're going to encrypt the VMDK itself. We're going to still have all the concurrent volumes and everything like that. So we're not going to do it on RDMA now. We're going to do it on the VMDK with all the other VMs and all the other workload going on. Let's see what happens this time. So here we go again. We have our screen on the left-hand side, in case you just joined us. We have little or nothing going on the array. We're going to go and take a look at the events. We're going to make sure the event log is cleared. We're all set. So basically, let's start off all of those 10 workloads again. Here we go. And all these are the IO zones that he's running on each individual VM. Each individual VMs, 260,000 files and folders. And so we've started that workload again, just like we had before. So it's in the lower right-hand side. You can actually see the workloads and all the 10 going on. In the upper right, we're going to start the Wanna Laugh ransomware. So here we go. I'm going to magnify it up. So on the top, you can see the percentage, and then below it, you'll see the latency, reads, writes, bandwidth, and of course the IOPS there too. So this time on the VMDK, it took us a little bit longer to find it. At almost 10% is when we got the alerts. Still not bad. Not 4%, but 10% is still better than 50% when half of your array or half your volumes are gone. So not so bad there. Thanks again for watching the video. I look forward to any technical questions or feedback. Reach out to Tom and I, and we can't wait to see you at a future event.